All right, so let's finish this problem before we continue with the discussion of these diodes. So we have this circuit, two ideal diodes. There might be an issue with the recording that I was having for this problem, so I'm not sure how when it was cut. But the solution was that we assumed, like the circuit before it, that both diodes were on. So if D1 and D2 are on, you could quickly calculate the current here because you know the voltage drop across the resistor and the voltage, this current here, right? And because, you know, once you assume the diodes are on because of their short circuits, you will have zero potential here. So this node, the entire thing will be 0 volts. And you can calculate the currents quickly based on that. And then if you do that, what we did is that we noticed that ID2 is 2 milliamps for that circuit, but ID1 turned out to be minus 1 milliamps, meaning that D1 cannot be on. You cannot have a negative current through the diode if you stick to the convention that we have for the direction of the currents. So what this means is that the assumption was wrong. So what do we do now? So we made an assumption, we already solved the circuit, but as it turned out, our assumption was wrong. Well, the only thing you can do is that you can go and make a new assumption, and hopefully this time you'll be right. But very easily you can see here that you have two diodes, so you have 4 possible situations. You can have a situation where both of them are on, a situation where both of them are off, and 2 situations where one of them is on, the other one is off. And if you're unlucky, you know, as you're guessing the combinations, you know, which one is on, which one is off, you may actually have to make a lot of wrong assumptions. And each time that you make an assumption, remember, you have to solve the circuit, right? So it can take a while for you to reach the correct solution. And therefore, it is very important to make educated guesses. Initial assumptions that you're making, they should, you know, be based on something that you are sensing about the circuit. So in this case, for example, we made an assumption, we already solved the circuit once, and it looks like D1 cannot be on. So my next assumption is going to build on what I already learned from the section in this circuit. So I'm going to assume, it looks like D2 doesn't have a problem, it looks like D2 can be on, but D1 is the guy or the diode that is unhappy. So let's just assume that D1 is off and D2 is on, right? So I learned something from that calculation. It's wrong, the assumption was wrong, the circuit is not going to be like that, but it looks like that between the two diodes, it was D1 that was unhappy. So I changed D1 to a off diode. The circuit that I have over there then becomes this. So D1 is off, I replace it with an open circuit, a resistor here to minus 10 volts. It's a 10 kilo ohm resistor. And then over here I have my D2, but D2 is on, so I replace it with a short circuit. This is ID2. ID1 is obviously 0. And plus 10 volts and 5 kilo ohms. I need to solve this new circuit. With new assumption, I have a new circuit, and the goal is still to find this V out. So let's calculate ID2 again. It looks like it's not too much work. I can show that ID2, well, if you look at this circuit, you have a current going from this power supply to this power supply. There's just one path for that current, nothing else is in there. So you can assume that the 5K and 10K resistors are in series, and it's easy to find the current through that series voltage, a series resistor combination. It's the voltage at the top minus the voltage at the bottom divided by the sum of the two resistors because they're in series. And if you do the math, it's going to be 20 over 25, and that's, how much is that? So that's 0.8 milliamps. I actually need a calculator here. Okay, so this is larger than 0, and therefore D2 is on. D2 is happy to be on. We assumed it is on. It looks like it can be on. It doesn't have a problem with that. But what about D1? So this is where D1 is. This is VD1. ID1 is obviously 0. But, and because of the direction of D1, remember D1 is pointing downward. So VD1 is like that. Is D1 on or off? I need to check that, right? So for D1 to be off, I cannot talk about the current here. Current is obviously 0. I should look at VD1. I need to figure out if VD1 is less than 0. If VD1 is less than 0, then D1 can be off and everything will be good. My assumption is valid. So to figure that out, I calculate VD1. To calculate VD1, I notice that VD1 is 0 minus V out, right? 0 at the top here, V out at the bottom here. Okay, so VD or minus V out. So if I calculate V out, I know VD1. Now, what do I have here? It's a linear circuit that is left. There are 2 resistors, 2 power supplies. Linear circuit, so I can use superposition. And I can use superposition to find V out when I apply those 2 10 volts. Or you can use KVL and KCL, but I'm just trying to show you that once you have a linear circuit, even if you initially started with a non-linear circuit, what I'm dealing with is linear right now. I use superposition. So V out, the other thing I do is that I use the voltage division rule that I talked about earlier. So I look at applying the 10 volt supply and figuring out V out based on the division between the 10K and 5K, and then apply the minus 10 volt V out voltage and figuring out the voltage division between 5K and 10K. So it's the 10 volt that I'm applying first. Okay, if I'm applying the 10 volt source, I'm looking at the voltage here. So 10K is the bottom here, 5K is here, so it's going to be 10K divided by 15K. Then I apply my second voltage source. It's minus 10. Okay, but when I'm applying the minus 10, this is the resistor that is going to sit between the middle point and ground, because the 10 volt is now removed from my circuit, right? When I remove a 10 volt voltage source, I replace it with a short circuit. So this is actually now a short circuit to ground. So the voltage division then gives me 5K divided by, again, 5K plus 10K, which is 15K. Okay? So it's 2/3 times 10 minus 1/3 times 10. So this is 10 times 2/3 minus 10 times 1/3. So this is going to be 10 over 3 volts. Okay? So V out is 10 over 3 volts. Therefore, VD1 that I already have from up there is going to be minus V out and is minus 10 over 3 volts. That is less than 0, which is consistent with our assumption that D1 was off. If D1 is off, the voltage drop across it has to be negative. So D1 is off. Therefore, I have verified my assumption. D2 is on, D1 is off, and these are the same as my assumption here. So fortunately, in this case, I actually made the right assumption, and those should be the values for the output voltage. So that's it for the discussion today. On the slides, you have a couple of other circuits, starting from a simple one to a more complicated circuit. So please do go through these on your own and solve them, again, including the suggested problems that you have from the table from the introduction lecture. Go through these, make sure you know how to analyze linear circuits, make sure you know how to analyze simple diode circuits with one diode or multiple diodes with the ideal diode assumption. And in the next lecture segment of the lecture, we're going to talk about, what do we use for a diode in real life? Obviously, the ideal diode, the name is indicating that it is ideal, it doesn't exist. So what is it that we can use to get most of what we want from an ideal diode model? It's going to be practical, so there's going to be differences, but what is it that can do the function for us most of the time, or most of the functions?